Hey class, let's talk about part 2 for dynamics. That means we're looking at our force equals mass times acceleration questions. So usually pretty simple formula to go through. Here's the little rewritten algebraically one, so if you're looking for acceleration or if you're looking for mass. But let's go through a couple of questions here, and then one that has to do with gravity. Gravity seems to be the question that stumps students the most. So question 3 here, I'll put in a gravity question, and we'll go through it. But let's go through a few questions here. So let's go through question 1. Let's talk about someone who's running down the sidewalk. What kind of force do they have with them? Okay, so let's say they have a mass of 60 kilograms, and they're traveling at a speed of, we'll say, like 3 meters per second, which is pretty good. All right, so what kind of force are they having to exert, or what kind of force do they have? Like if they were to hit somebody, what is the force that they have when they are 60 kilograms, which is what we're using for our units, and then 3 meters per second. Well, you just go mass times acceleration, so you get 180 newtons. Force is measured in newtons, so a capital N. Okay, so pretty simple there. That's the force that they have if they were to hit something. Okay, let's go a different way. Let's say we're applying a force to something, like a box. Like let's say you're pushing a sofa. Okay, so let's say your sofa weighs, I don't know, let's say 30 kilograms. And you're applying a force. So you're giving a pretty strong force. You're going to give a force of 230 newtons. So you want to know how fast can you actually accelerate that sofa? Well, if I go, and I'm looking for my acceleration, if I go force divided by mass, so if I go 230 divided by 30, 230 divided by 30, there we go. I get 7.666 on forever, it's repeating. Meters per second squared. That should be squared. Sorry, up there. This is acceleration. So there, I'm getting this couch is going to accelerate that fast because I'm pushing so hard. Okay, so again, I'm not going to go through too many here. This is a pretty simple formula to kind of go through. But the one that I want to go through here is I want to talk about this. Okay, let's say there is an object. Okay, we're going to call it a piece of rock, like an asteroid from like the actual. From outer space, it somehow got into our atmosphere, so now it's there. We're going to say there's a large chunk, okay, so there's going to say a mass of 200 kilograms. Okay, so something pretty heavy. All right, we got something that's close to 500 pounds there, piece of rock, and that's all I leave it at. And I say, what is the force of that rock when it hits the ground? Okay, and people are like, well, I don't have enough. If you remember, again, gravity always has an acceleration of 9.8 meters per second squared. So a lot of students get confused that like if you only see one part of it, if you only see a mass and something is falling, a lot of students get confused because like, well, I don't have enough. I don't have an acceleration. I don't have a force. What am I supposed to find? You always, if it's falling, it always has the same acceleration. It always has an acceleration of 9.8. That's a horrible 8. That's still a horrible 8. Let's try that again. 9.8 meters per second squared. And then you can find what the force of that actual rock is. So now I'm going to go 200 times 9.8, and I get a force, like this rock has a force of 1,960 newtons. So that's the one question that sometimes actually screws up students when just kind of using a simple formula. But there's the way to use it. This should be pretty straightforward. So looking good to have enough sheet of work for that, okay? Next little video, we'll talk about net force and opposing forces. All right, have a good one.